Thanks, Dr. Lee, for this introduction. And it's a great pleasure and honor for me to talk at the HHDT conference. And this morning we heard a lot about physical AI, robot, and embodied intelligence. And this afternoon, Chris has also given an excellent introduction how the knowing, doing, prediction will be the future and to fuse. And also I heard some of the industry foundation model in Foxconn practice. And my research interest, as we all say, that I started with starting the artificial intelligence almost 30 years ago. We experienced also the winter time of artificial intelligence. Now, 3 years ago, we see the ChatGPT, and everyone is talking about its explosive growth. And normally our expectation of technology improvement is linear. If there's a big gap, and what is the chance and opportunities, and perhaps a question mark should be there. So what we are working on is with embodied intelligence. We are aiming to using AI to implement the richness of physical equipment like robot, machine, or factories. And usually we use a lot of automation method, and by increasing the richness of functionality, usually we added a lot of mechanic parts and to let this to realize more functionality. But now we have the chance to generalize the machine intelligence by adding intelligence to the mechatronic system. So now we see the AI on device is a very important topic. AI multiple large language model will coming from the cloud to the edge, and that's I hope the robot will be also part of it. So to summarize why this AI is growing so fast, we all know this computing power. Foxconn is expert on that, exponential growth, and the big data now moving from the big data to the huge data, all available data, and this large language model become possible. And also the algorithm and now is developing very, very fast with the aid of AI and large language model. So we have seen the rapid progress in the vision part, so-called detect anything has been becoming possible. And tomorrow I meet the author of this segment anything Dino group in Hong Kong, Shenzhen, and they are the best author and the group for this detect anything algorithm. And language part, we have seen rapid growth, and understanding any text seem to be a breakthrough. Next one is the robotic part, and how to let the embodied agent to realize the robot GPT, and just from the inspiration of ChatGPT. So now we have the transformer and diffusion model, and if we can let the embodied agent has value, and also the structures, and we can see the embodied agent robot learn how to learn. So meta-learning and sim-to-real now are very, very effective method for implementing both software and real agent. And now we have this text, image, and deep data, point cloud, and event stream, and audio video, tactile, and robot joint angles. And this data includes the static data and also the real data, what Chris also mentioned. And they are live streaming data and also perceived from robot. And with all this real-time data and also some text data, and how to implement the high degree of robot now is becoming very, very interesting. And there are currently two strategies based on the foundation model. And if we use the visual language foundation model and then take some foundation parts and those modular implementations, we can see these different planners and controllers can be realized, and this is current most suggestive way in the robotic part and in the robotic societies. And another methodology is to be more end-to-end and try to use the robot foundation model with some end-to-end method and to train and also to let the cerebellum and the robot foundation to be one end-to-end model. So how we can do this together and to realize really the vertical applications. Tomorrow morning we have heard also how the creating value with AI and embodied intelligence is the key to avoid the bubbles. And I think AI and robot combined or solving real problem in any of this field will create $1 billion market. So, but how, and especially in manufacturing, future transportation, medical, and agriculture, and household, and education. I'll give some of the examples of what we have done in the past. So in our last 30 years robotic project, and we work a lot and about how to integrate the perception and the actuation together. This is a European project which we have participated to implement the service robot to help the elderly people at home and also do some shopping outdoor. And we publish the modular software and architecture in this engineering first issue. And also, we 20 years ago, in my assistant professor time, we have implemented this mobile manipulators equipped with laser scanner and also force torque sensors and hand cameras, which can work in a laboratory automation environment. I think this kind of robot is now becoming an important implementation agent for realizing the AI for science and AI for engineering. And now we are very quick at designing the procedures, but how to let the automation, really the embodied agent to implement this day and night and 7 days a week, this automation procedures. Now we have a good chance to use embodied AI for engineering, for realizing the science, and even bimanual manipulations will be also available now for helping people to do biological, pharmaceutical, and also the virus processing unit. So also in our previous research, we have been already proposed some method for experience-based learning. So we do believe this interaction with the environment continuously will be the key role to deal with complex real world. So this European project, which I have coordinated, is called the RACE project. This is the acronym of Robustness by Autonomous Competence Enhancement, so that the robot continuously learn in the real world, and like a robot serving a restaurant. And we do believe this small task, easy for human, will equip the AI system with a lot of knowledge, for example, spatial knowledge, resource models, action models, ontologic models. and altogether is a matter constraint satisfactory procedure, and how to let a hybrid reasoning and the software framework can evolve through the interactions. Also the temporal models, action resource models, and the ontology spatial models. And we have tried to let the robot learn this 8 kind of knowledge and to serve new coming customers correctly. And this architecture is actually a high-level implementation of using language and manipulation.
How do I get rid of my old robot?
This is a generalization of our robot from restaurant service to library service, and the student tell the robot to take 1 book. The robot took 2 books back, and it's sure that has some intelligence to understand this context and the future. And through this experiment, we try to let the robot learn more important indices like description length, how to instruct a robot to use a very short message and to increase the level of interaction intelligence. On the other axis, and we want the robot to shorten and to minimize the mistake and errors, what he understands from the world and what the real world is, fitness to idea model. And we have tried the continuous experience-based learning has been able to let the description length and the fitness to idea model shorter. So now we all know that this reinforcement learning is very, very important, and we have tried this high-level reinforcement learning already in this project. And also we heard today about the industry, so physical intelligence. And in this area, so actually we have done also a lot of physical environment, and Foxconn has a lot of scenarios also.
我将把猕猴桃放到黄色盒子里。
Yeah, and we all know this automation in some structured environment, Foxconn has achieved also a lot of progress. And this startup is called MakeMind, and we are using this 3D point cloud camera based on structured light to detect the 3D environment very precisely. And for industry applications currently, the precision, robustness, and high level cycle time is the most important. But in the future, if the robot, as a versatile robot, as mentioned by the ABB Vice President, and go beyond from a factory to home and to hospitals and to field, and in agriculture cases, this general understanding will be very, very important, generalization issues. And we have been concentrating a lot on the manipulation devices. Actually, for general assembly tasks, some tool changes also be very effective, and we can use also this parallel gripper to change the tools and do a lot of operations for similar iPhone assembly task. But in the future, we think that our multi-finger hand structure will be the main solution for using one platform to do the versatile household and also the industry applications. And we have been continuously developing different hand architectures from 5-finger and to agile robot and to a very sensitive sensors can detect the temperature and also the sliding forces. And in this PhD work of my group, and Philip has developed this double stretchable tactile sensing glove, and the aim is to collect also tactile data during the manipulation. I think this is one very, very key aspect for embodied AI in the real world, especially for close interaction with between robot and the object. So we have been using this modality, the third modality, beside the vision and sound, and this is the touch information, and have been let the different users to show how the tool usage can be associated with the very delicate tactile sensing. And these are becoming, as some of the experiment we have been implementing with the dexterous manipulation. And this work was before the COVID, and we worked with British Health Agency, and that time they let us, our robot, handle the virus samples. And at the beginning, we didn't know that why this is important, but after COVID, now we know this automation in P3, P4 lab is a very critical issue. Now the robot can be really massively commercialized. And also in our group, we have continuously find a new method to teleoperating the robot, and without using VR, but using real devices. And this is also a PhD work that we can just use our hand to instruct the robot to do different tasks. And also, if we started the human hand, now we all know that the hand manipulation is more difficult and more challenging for in compare with the whole body motion. So, but if we control this 26 motors together, it's now still impossible. And but if we classify the main human dexterous grasps like tripod, palmar pinch, literal writing tripod, and the para extension, adaptation grip, tip pinch, and the literal tripod. And for each of this dexterous grasp, we can actually reduce the action dimension to 5 or 6 principal components, because for each of the grip and all the motion are very closely related. So for this work, we have won the Robio Best Paper Prize. And if we consider the final automation station, this is the dexterous manipulation in the industry, Foxconn has a lot of very important scenarios for us to solve this multimodal fine manipulation problem. And I've been working with iPhone assembly factory in Zhengzhou for almost 6 years. It's my hometown in Zhengzhou. So 60% of the newest iPhone was produced in that factory. So before COVID, it has about 300,000 workers just doing this assembly. And now the labor number is about half. And we see some progress with automation. We cannot show a lot of real application in the iPhone assembly, but here is some mock-up scenarios, and with this is also very useful for server assembly. And actually, this high challenge how to use tools, very small, teeny, and have very small accessibility is a huge challenge, not only for engineering aspect, but also for AI part. And we have also just implement some method to collect the human tool usage, and not only the position, the orientation, but also the tactile information. And these are all very valuable data for later physical AI learning, especially regarding with the very important dexterous manipulation based on tactile information. So if we move from the industry scenario to the daily scenarios, and this high friction fingertips, and also multimodal sensing and position velocity and torque control will be also a very important issue. And so this recently humanoid become a very hot topic, and a lot of people are asking us if humanoid really necessary. So my answer is that the bimanipulation at least is very useful. And why we human use bimanual, you can see if you have one arm, and the efficiency and a lot of tasks cannot be performed. And we have also tested approximately about the iPhone, and also the computer board assembly, and over 90% of the tasks can be implemented by one hand holds a tool, and then we use another hand to work together. So this tool usage and the bimanual manipulation, and to have very efficiency and problem solving in the 3C assembly is the way that we must go. No? So the legs or the wheels is another solution, but the upper body should have this human-like configuration. So we have to test a lot of this tactile capturing, and for a lot of different applications. And my student have published also how the tactile sensing model-based can be fused together, and to be used for this deep reinforcement learning network. And also we have got a lot of inspirations from the Foxconn, so engineers in the factory floor. So this picture was also given to us to think how the robot can do it. So to fix this soft cable inside this server chassis, and not only for electronics, but also for car manufacturing. And this soft object handling is a very, very interesting topic. And for small parts like these electronic devices, and we have to at least recently had to use some specialized grippers and for implementing this manipulation. But if we talk about this general manipulation, and in Germany, actually, this agile robot has been working with Foxconn very closely together. It's also Foxconn has invested twice in agile robot located in Munich, and recently we have won the production efficiency award. Just let the robot do the soft cable routing and also soft cable insertion, and this actually, in our opinion, will be the most challenging and important part for embodied intelligence. And also in agriculture applications, provides very interesting scenarios for our robotic tactile sensing. We all know that harvesting apples and tomatoes is relatively easy, But for very fragile objects like blueberry, strawberry, and these very sensitive sensors and the new soft structures for grippers are very important. Recently we published also the soft robotics and to handle this very fragile fruit. And fruit harvesting will be also a very important area to bring value to the real world. And the multimodalities actually was mentioned also several times. I don't need to go to too much details, but if we consider humanoid, and let a humanoid robot realize all the very fine structured dynamic modeling, and let the humanoid hand arm use tool and for very dexterous manipulation, and also to let the robot head to interact with people or with us, human being, by using very natural and empathic tools, and this is very challenging. And this is also the way that we want to handle these different modalities together. So to combine the position, vision, audio, force talk, and haptic devices, and then to implement very fine challenging manipulations. So predictivity was mentioned also in the first speakers of today's workshop. Actually, we started interdisciplinary project 10 years ago. It was 2015, this cross-modal learning project, and we concentrate on the adaptivity, prediction, and the interaction capabilities, and how to catch this essence of human capabilities and then transform this to a real artificial cognitive system like robot. So this cross-modal learning, and including the prediction and the interaction, is the very important feature of human cognitive system, and also what humans are really good or much better than artificial AI system. Although we have seen very good examples of pre-training, but online adaptation is still far away from human capabilities. That's why we want to learn from human brain and from human cognitive systems. Actually, if we see the brain part and what the ChatGPT can implement is only part of the language part, and now this multimodal, so-called multimodal, involve a little bit of vision, a bit of language, but we see a lot of auditory and tactile and somatosensory motor like cerebellum is still unsolved. That's why the first speaker talked about the doing and the prediction will be the next blue ocean for AI, for the tools and applications. Actually, if we check how human can adapt better, so we see this human use a lot of very important aspect like attention, and if you have good attention, and you process much better, and if you have strong emotion, your memory is better, and you can use synergies. Sometimes you don't do everything parallelly, just some uncontrolled part, and you use also for extremely reliable scenarios a lot of redundancy. And all these aspects are the essential mechanism why human is so robust and so adaptable. But the current robot only have a little bit about attention. And we also use a lot of inhibition to select only useful data for our dynamic purpose. That's why we are so power efficient. With 20-watt brain, we can almost compete with this big energy consuming ChatGPT. So if we consider the online learning of different modalities by visual, audio, somatosensory, and combine with some of the artificial sensors like sonar, ridge finder, brain signals, actually we do believe full modality will be the central issue for also for deep learning. And now we have also discussed with a deep learning expert to implement the audio, tactile, and text together, and to realize early and later fusion and a lot of intervention together. So there are not so many implementation of all the three modalities in real robot yet. And my PhD student just published in the TOF Robotic Conference. It's the first one that the robot integrate the tactile and sound and visual information together. I let my student Michel Goerner to play guitar, but he liked Chinese culture. He implemented this guzheng playing, and also hired a teacher to learn Chinese guzheng playing. But in this part, and we want to study how this three modality synchronization and will be like human-like control and perception architectures. And in this cross-modal learning project, we have published over 800 joint papers, and it's an interdisciplinary project between neuroscience, brain science, AI, and robotics as a very large project. And one of the over 800 publications is about how to code the vision information, the language information together. And in that year, we have implemented this so-called image capturing problem, and gave a picture and let our system to describe what happened in the picture. But now we see that the multimodal system, so using text to generate figures, and also to generate videos, now become a very important function of multimodal system. So 20 years ago, I talked with my students. I gave them a task, so to let them speculate in 10 years if our robot can read all the books in his brain, and what will happen. So we create this picture almost 20 years ago. But today we really see that with the generative AI and large language model, we can really see that all the parameters, all the data available can be fused to one model. And we have seen in both applications, both previous talks, and how these different models compete with each other. The foundation model timeline so evolves also very fast. That's create some of the result, all the examinations, large language model, all the digital intelligence is now very important. But we have been able to see some of the agentic AI also have this kind of value, and like embodiment, and in the soft areas, and from chatbot to reasoner to agent to innovator, and also to let different agents coordinate together to complete more complex tasks. and like this deep research, and we can let this different agent work together and generate the procedures you want to create. But if we want to realize these robot procedures, we need really physical AI like grasping and few shot learning. And we have tested also some of the diffusion foundation model for grasping. And we can see this robustness is still very low. And this is not useful for this Foxconn application in the factory floor yet. But the dream of moving from ChatGPT to RobotGPT is very fantastic for all the societies and also for the investors. That's why embodied AI is becoming the hottest investment track all over the world. And if we move from the information processing to disembodiment and to embodied intelligence, actually we are dealing with the information in the temporal continuity, in the spatial continuity, and also in the value continuity. And later, if we want some intrinsic value, motivation, and self-aware can be also possible. But we have to discuss very clearly the ethic and governance of AI. But in general, embodied AI is focusing agents to interact with the physical environment and try to realize the scaling laws through a lot of interactions and better data. And to integrate the brain, cerebellum, perception, body together, this close coupling will be the essence, and even end-to-end will be an issue. Actually, in the robotics, so embodied intelligence is not a new word. And we have tried to implement this passive dynamic working already 10 years ago. So to integrate the model, mechanics, control, and intelligence together, and we have been able to create a robot using just one word to walk, to be able to walk more than 130 kilometers. And this is already an example of this close coupling make some very special function evolves. And today we have heard several times about artificial general intelligence. And I'll say if we talk this general intelligence, the real world, in the physical world, it's still not easy at all. And in the digital world, now we have seen some logical reasoning. That's the blue part. AI can replace some of the functions of human beings in writing and drawings. And in the physical world, we have also seen some impressive demonstrations of robot hardware, dancing, running, boxing. I call this growth motions. But for real factory applications, this fine operation, fine manipulation, fine environment perception, that's what we need. Foxconn is named as precision assembly. It's the main procedure, and how to realize this precise operation, perception, operation, and interaction. This is, we have seen only a small portion still possible, and how our human intelligence can still surpass the physical AI or embodied intelligence. I think at least 10 years are necessary. So we're still very far away. But we also see the rapid progress in humanoid. So Now, in this sense, the robot, the cerebellum control and learning and the big data-based control has to play a very important role. This my students droid robot. They have participated in the half marathon running, 21 kilometers, without changing batteries, and this already shown the gross motion capabilities. But as we mentioned, the manipulation part is very important. Also, the empathic interaction, and we try to integrate this face emotion expression and manipulation together to create a really human-like robot. Elderly care is another very important vertical applications, and so a lot of people are asking us when we can make use of the robot to make my retiring life more independent and valuable, and not let our kids to serve us. And recently, these physical interactions with holding and also assisting becoming also a very important area for embodied AI. This is several of my students, two of my students starting their companies in Germany and in Shanghai, and to try to realize part of the functions for elderly care robot. So Agile Robot, as I mentioned, is a close partner of Foxconn, and twice has Foxconn invested in this company, and this company has the best force control technology. Now also with FANCA, with this force control, we have implemented some tasks. But what we can so dream about is the birth of embodied AI, to let the user to just use little coding or no coding to deploy the robot in the real environment. And that will need also the robot have a lot of rich and robust skills, and how to reach these skills using this nature development. So just through a lot of interactions and good data, and from the robot passive perception to interact perception to intensive imagination to embody the execution, is now the main strategy for implement this data-driven robotics. And I've been working with robotics for 30 years, and in the first 20 years, and we use a lot of models and control model, differential model, kinematic, dynamic models. We have edited 72 books each about these models. But now the database time comes, someone asks, do we still need these 32 books? And perhaps the data can solve all the problem. But I'll discuss with you this if this will be possible. But actually, in our continuous robotic time, and we have been considering the end-to-end learning also almost 20 years ago. So this side includes all the force and position sensors, and these are the robot control parameters. And 20 years ago, we don't have a lot of computing power, and we can only use a 5-layer so neural network, but it's already work for this manipulation task, one-arm and two-arm manipulations. And also we, in that time, we already consider how this end-to-end learning will be possible. And so we are prepared, actually. So only in that time we are missing the data and also the computing power. And recently we have seen also in the last talk, so this data collection for robot, now starting from the X embodiment project of Google, now all around the major industry world, including Beijing and Shanghai. So the government assisted the data collecting center. They employed a lot of physical robot and using VR teleoperation and to let the robot try to do different tasks. And actually, this large language model and the visual language model, or we are now working on visual tactile language model. So for manipulation, it's still just at the beginning. And we just published a survey paper accepted by the International Journal of Robotic Research. We have read over 500 papers, but they are still not being able to solve the fine manipulation based on the tactile information yet. But we see that there's a huge interest and a very fast development in this area. And how to realize the RoboGPT. And we have also sought some of the method. That's one of our recent publications. And let the planning method with the ChatGPT generate the action sequence fused together. And we are able to increase the robustness of this manipulation procedure to 85%. And if we have a general platform like humanoid robot, we can let robot also do different tasks like our human, and do the household work and do playing, and try to use this transformer encoder, transformer decoder to have this general intelligence. And also the scaling law in the physical world, if that will be possible. We haven't seen a lot of examples in the physical world, scaling law. But we have tried with the Galaxy robot together with the scientists and the researcher there, and we are able to generate a billion level of dexterous grasping data. And of course, most of them are synthesized data, and for different kind of grasping method. And we are able to see some of the robustness improvement. It's not like the digital world scaling law, you have a sharp increase in the emergence part, but we do see that to the billion level of learning data, the robustness has been improved quite a lot. And with this data-driven method, if we have only the perception part, we have experienced a very big progress, so-called deep anything, segment anything are already possible. And reason anything, grasp anything, manipulate anything, or for Foxconn, assemble anything will be perhaps the next 10 years questions. Now we are still working on that, from perception and the central general manipulation. And now in the academic areas, computer vision people are working on just from one image or through image from two cameras, you can guess the depth. Now depth anything now seems more and more possible. And based on this images, segment anything, as I mentioned, this Dino algorithm working very robustly, and give a picture you can segment very robustly, and using VRM Python code interface to generate the reasoning about robot manipulations. We are also still publish several papers, and grasp anything. I show some of the grasp learning in billion level questions. The next challenge is about manipulating so soft shape changing like cables and for the server applications. And that's recently we can expect also big progress based on good data. Manipulate anything. That's some of the tasks should be realized through action generation and also subtask verification, and assemble anything we'll report it perhaps in the next meeting more. And in the robotics, we have the problem that some really multimodal data should be collected. So this dimension of multimodal data will be at least 1 million times more than the current text data. So in order to let a robot work like ChatGPT. So, but that's almost impossible if we don't consider the structures of robot and the real world. Actually, we should consider the inductive biases for robot, like shift equivariant, promotion equivariant, and geometry, symmetry, so on and so forth. Not everything learned from the beginning. So we do believe this model and the database method will be definitely necessary. So this foundation world model, and we heard also from tomorrow morning's talk, and NVIDIA had this Cosmos partially realized the physics simulations, but we do know that in the interaction between robot, between the cable, between the medical system, between the tissues, still a lot of models still unknown. And we should work with mechanics and with biomechanics and with a lot of discipline together, try to get this world foundation model more complete. But at the same time, we can use the foundation model with the full modality data together, and try to let this moving from structured intertree environment to the unstructured open-end, so household and then agriculture environment, for example. And the more complex, more open the environment will be, more modality data will be needed, and more uncertainties there will be. And then we have to model-based method and data-based method should be considered together, and now to use the advantage to avoid the disadvantages actually of the data-based method. And from computer vision, we already seen some of the examples about it's modular explicit modeling, and precise model selects adaptive, but very good for interpretability, computational efficient, but the database method is very adaptive without so implicit fusion, and keep all the information inside, but it has a problem. It's not the safety guarantee, not impenetrable. So how to do it together? We have done also some practice. So this is one of my postdoc, Zhong Lin. He integrated the human kinematic model and also the perception, and reconstruct the human motion very easily. And he is now doing something to democratize this 3D motion reconstruction to create special effect videos. And also through the model-based method plus the reinforcement learning, and we create also the humanoid robot, the ping pong playing, but the most effective demo is this robot, and it has also won the Guinness World Record. And my student play with the robot 1.5 hours, 6,000 back and forth, 6,000 times back and forth. And the robot is improving himself every day. And I think this is also a very good example of this model or control model, and also the learning method. And in this computing, Chinese people are good at ping pong, and we do a lot of examples with ping pong. And this control can realize the one-stop bulk balancing, and also can keep the trajectories. And later we hope to show more the combination of model and database for robot assembly. We have done some of the assembly in BYD battery assembly, and this is still in a large size, and later we'll be glad to see more application in the Foxconn very teeny iPhone, iPad, and the server applications. So now I think a large language model combined with reinforcement learning is also entering to a new era that in the different phases it can continuously, for example, by folding soft tissues, and this increased success rate for single task is all becoming more and more important. And this year, the largest robotic intelligent conference was held in Hangzhou, together with AI Research Institute of Foxconn. We published also one paper. It's a small start, and try to integrate this multimodal affordance prediction, and within the manipulation cases. Shangqing, my PhD student, has been in the bridge between the AI Institute and my research institute in Hamburg, and I think it's a new era of collaboration, which we can further deepen and also broaden in large scale based on our previous good collaborations with Foxconn factories in the last 5 years. Today I'm so happy to meet Terry Guo again, and we worked already before COVID. He introduced me also the iPhone assembly factory before COVID. Since then, I've been always, if I visit my parents in Zhengzhou, I always in this Foxconn iPhone assembly. And we are making progress, but still far away from replacing human. We hope that in 10 years, perhaps about 80% is my guess. Okay, so that's a summarize, and we have a lot of challenges to realize embodied AI and AI chips, and also embodied arranged network. This cerebellum control, I think, will be also a very important task. And also the evolution, multimodal AI in social context, and leveraging both real-world synthetic data, and we mentioned that before. I come to also to this, not go to too much details. And together with Shangqing, we draw this data flywheel for physical world. And we're starting from the data curation, and for all the real-world, real-time data, we can do the multimodal perception and model customization, model evaluation, and ASIC guardrail. So if this will be applied to our scenarios, and we can have one rotation, collect more high-quality multimodal data, and hopefully, and we can improve this data bottleneck problem for physical AI. And we all know that teleoperated data is still very rare. This issue is much more difficult than autonomous driving. But we do need, actually, as I mentioned, at least 1 million times more data what we are using from ChatGPT. So 15 trillion tokens are not enough at all for embodied AI. So today also some of the speakers mentioned about the compression of the large multimodal model, and together with Dr. Yao Yuan, also interdisciplinary trained PhD student in our project. He's an assistant professor now, and we are working on the multimodal edge computing, and we want to see the scaling law of compression and by sparse coding, and also even multimodal model can be realized to let this model runnable in embedded system and in pad, later in phone, so on and so forth. And today we heard already the importance of real data compared with the offline data, and to move from the multimodal to omnimodal, to from static to offline data to online streaming data. So this mini CPM ChatGPT 4.0 level for vision, speech, and multimodal live streaming is a recent publication, and we hope to achieve more for robotics. So also the architectures for embodied intelligence will be the next topic, and end-to-end learning like autonomous driving will be not the solution for a robot. So human beings has much more capabilities than just moving around. And then this hierarchical network resembling the brain of higher animals, very important. We are still working with neuroscientists and psychology together and try to find the integration of this hierarchy and end-to-end learning, function-based end-to-end learning for the future. And recently we published also how to make use of the action planning based on large language model, and use continuum learning and reinforcement learning for robot skills. We do believe in the recent future. This will be the practical road to achieve large language model based and very precise, robust, high cycle time, and for the factory usage. This is our suggestions for the architecture issues. So to summarize, we believe this embodied intelligence in factory, elderly care, agriculture will be really ASIC aware, and for the benefit of human being. And science, different sciences like mechanics, neuroscience, biomedical, all these sciences should be very useful and helpful for embodied AI. On the other side, embodied AI also, such as robot, will be also helping for sciences, better cognitive science, understand what we model ourselves, to validate it, and to do better medical experiments, health experiment, biological experiment to serve the science and engineering. So in this sense, we hope all of us can work together for a better world, and by improving the embodied AI technology. Thank you for your attention.
Thank you, Dr. Zhang. Now we open the floor to the questions. Is there any question?
Based on your PowerPoint presentation, I saw you have AI with textile recognition. So my question is, you train your artificial intelligence based on, I assume, is modeling and as well as visual cues. However, like for example, I have an egg that has two forms usually, like one with pill shells. So one without the eggshells. So how can your robotic textile hand can recognize which one is which?
Yes, that's a very interesting example. And one of my PhD students working on the physical model also together. So In the practice, there are some other examples. For example, glass cannot be recognized by vision sensors, but by using model, we have published several papers just by let the robot handling transparent glasses. And this egg with shell, without shell is another example. We do think this affordance physical models combined with tactile sensing will be the next solution because they look like it's very similar.
Thank you. And one follow-up question. So I also have a question like, how about like when we know you give your robot an egg, you kind of is one thing. However, if you mix two textural feeling things together, for example, like sand on a mob or something, how can the robot tell it's a sand on the table or something? You know, do you understand my question?
Yeah. So I think it's still not solved, and now in different conferences we have a lot of competitions, and I think this will be a good example of competitions to let different teams deliver a good result. Tomorrow I'll be in Shenzhen. In Shenzhen, I helped to initiate 2 years ago about the embodied AI for dexterous manipulation. Tomorrow, we have given several tasks every year. Each year more difficult. Perhaps we can consider this for next year. Thank you for the suggestion.
Thank you.
Yeah, one quick question for you. Okay, my feeling is that to create a general purpose physical AI-based robot is extremely difficult, right? Because there are so many kinds of physics and so many kinds of scenarios in the world. So the future physical AI robot should be very application specific, only good at something. Okay? And then we have all kinds of different physical based robots. Is that correct? Okay.
Yes. Yeah. The final goal is to create someone like our human being and do everything, work in the focus on iPhone assembly and a little bit training to work in the hospital and go to the harvesting. So we human can do that, but the difficulty is still very, very high. I do not think it will be possible in 10 years. So, but in this 10 years period, and I think we can define the general purpose robot as an addition of different scenarios. We train specialists first in a local area because we don't have so big data for everything, multimodal. But for factory usage, we can train specialized for assembly. And we don't have this general gripper like our finger yet, but we can create some special fingers, only good. But also for dealing with different materials, have this generalization capabilities. And this controller will make use of the world foundation model and to increase the versatility in the future. And one by one, first this assembly, welding, and also elderly care, helping, assisting. We do this scenario by scenario. So I think that's the way before we enter the phase of really generalist humanoid robot. Yes.
Yeah, just a question. So, I mean, this is as you look ahead from a vision perspective, are there certain things that you don't think you can train a robot to do so people like us can keep their jobs?
Yes, it's an ethical question. And what I have shown in the vertical applications are real applications that you cannot find enough workers. And I think we should prioritize this application. They are very difficult. For example, assembly for for these young guys, 18, 20 years old, they are so quick. Our robot is still very small. But this work is very meaningful because the young people are also starting not to be interested in such job anymore. In Zhengzhou, during the COVID, you don't have enough workers, iPhones, so quantity become a problem. And now the young people just want to go to the other jobs and also agriculture. So if in the harvesting time you don't have enough workers, I think we do not want to create the general replacement of human beings. Just in the future, I think the society will be a human supervised robot and then coexist. And not to, I mentioned also, don't give the robot too much about their consciousness, motivation, and self-awareness. And we should let them to hear our instructions, to be our partners, not over us. That's very important.
Actually, talking about.
Hello. You mentioned, the stuff about the hand was pretty interesting, and you mentioned these grippers and also various sensors in the hand to feel motion. Can you just comment a little bit on durability and if there's any kind of steps to deal with wear and tear of sensitive things like grippers and sensors?
Yes, that's also very right questions. Now, this tactile sensing also becoming a very hot startup topic, and so this tactile information to visual information, and also the other methods that are over 20 methods for implementing the tactile information, but all of them added together are still very, very far away from our tactile sensing, and which can so fast and several million in one finger, and also temperature sliding forces together. No sensor can do that. I think we still have a long way to go to realize the human skin level, and I don't think it's possible in 10 years, but we try to realize partially our functions. Very important.
Any other questions? I think we still have maybe 3 minutes.
Chris.
So one interesting problem is always collaboration between robots.
Yes.
And you sort of mentioned that having two hands allows you to do things that you could only do, or you couldn't do with just one. But as you keep increasing the robots, then the challenge to communicate between the robots and to have a same view of what the next task is gets harder and harder and harder. So do you have a thought on what the optimal number of collaborative robots would be that balance that communication and increases the speed of completion of a task?
Yes, that's a very interesting question. In robotics, there are also special sessions continuous, but multiple robot coordination. For mobile robot, we can realize already several hundred. Now China has so many drones for demonstration, so over 10,000 drones can be working together. But for manipulators, also very interesting to think about the multiple arm coordinating together. For example, by harvesting, Now, if we use one arm, and it's very inefficient, and we are thinking on at least 10 arms parallelly to coordinate together. And recently, the Science Robotics also published one paper. So this one group of researchers has implemented this 6 manipulator work together and try to avoid collisions and with the environment together. And they develop a framework for that. But the real coordinations and also to let them have the same view or same understanding of the dynamic world and needs also not only method but also the close coupling of perception and control. Perhaps we need special chips for that. No? So that's will be also good opportunity to develop cerebellum chips later in the future. So considering the multi-robot coordination aspect.
Okay, I think it's about time. Let's thank our speaker again.